Hi and welcome to this YouTube video. Before we start, please forgive my voice as currently I am unwell. This video will be the design demonstration and verification for my project. This will be the final video in this series. In this video, we will be talking about the functionality of this project according to my specifications, and also I will be taking you through my brochure I created, and in short, I'll just be talking about everything this device has to offer, and I'll be showcasing everything I've done so far, from the code to the software, and to showing you how the device functions. That is what we will be starting with, how the device functions. So if I should place this is a project we built throughout the entire semester, and this is the Node-RED dashboard interface. So if I should interact with this LDR over here, you will be able to see the increase in the brightness. That is when I cover the LDR. But if I should leave the LDR alone, you can see that the light reduces in brightness. Again, if I should cover it, it increases, and if I leave it, it decreases. Also, too, you can see the display on the red dashboard, and you can see the graphs, how inversely proportional they are to each other. So when the value of the LDR is low, you can see that the angle of the servo is high, which will then turn the dimmer switch, which will then increase the bulb. But if more light is entering, you can see that as the LDR's value increases, the servo's motor reduces, and then which in turn reduces the light bulb. So yes, this is just the brief functionality of this project, and I'll be taking you through the brochure right now. So now I'll be going through the brochure. For this is basically for anyone interested in purchasing the device and would like to know beforehand what this device entails. This is the name I gave at the beginning of this project, called an Arduino-based remote light bulb intensity controller. And as you can see from a few seconds ago, this is the package I used for my device. It's a DIY, so sorry for the poor housing, but as time goes on, if there is available funding, we would make it a more suitable device. To watch this video, you can click this link. Please share the link to bring more customers in. If you have any questions before we continue, this is my contact info. Now, I've already showcased the device to you. I've already described what it does, the functionality, and I will still read it for you. As the world evolves, so does technology, and being able to use a technology that does not require human input is innovative enough. I bring to you this Arduino-based remote light bulb intensity controller, where it takes light intensity from the environment through an LDR sensor, and depending on the value, increases or decreases the light bulb So in the beginning of this video, I went through that with you to demonstrate how the entirety functionality of this project, and you saw how this device works, and you saw that it's very easy to interact with. Doesn't really require much human input. All the human input we need is to connect the live um the cable into your software. And I forgot to add, when I was showcasing um the, the design, but the specifications are is 18 centimeters in length by 11.5 in width, with a height of 7 centimeters. So it's quite it's really quite cute measurement. Also too is it weighs 0.33 kilograms, so and that makes it very light. It has 4 ventilation holes with a radius of 1 centimeter. In case where this device will be running for like for days and months, we will need we will need ventilation for air to pass in and out to cool down the systems inside. For the connection details, our dimmer switch takes 120 AC. Our light bulb also runs on that 120 AC. And our Arduino, our servo motor and LDR uses the current coming in from our PC or any software device we want to use, and that is 5 volts. So when I was showcasing the functionality of this device, I did not show you the inside, so you might not know what components we used, but these are the components we used. So I use an Arduino R3, a servo motor, a dimmer switch, an incandescent light bulb, and an LDR. The Arduino is the heart of this device. That is what sends information to the LDR and also PWM signals to the servo motor. The servo motor receives these PWM signals, and that is what the servo motor is mechanically attached to the dimmer switch, which then turns the knob on the dimmer switch, which then increases the light bulb or decreases it depending on the LDR's value. So all these components work with each other. They work together with each. Sorry. All these components work together well. And this is the schematic, the circuit diagram for this device. This circuit diagram only represents the DC portion of the device. As we can see, we have our Arduino Uno. We have our servo motor. We have our servo motor, and this is our LDR, which is in a voltage divider with a 10K resistor. So this is the DC portion of the device. So what is happening inside is that we have our dimmer switch attached to this, and then this dimmer switch is then connected to our light bulb. So that is the dimmer switch, and the light bulb is the AC portion of this device. And then we move on to our software interface. So as I was saying, as I displayed earlier onwards, this device displays an red dashboard where we can see the actual values in real time. So, and also we can see graphs to represent how clean our LDR and servo motor is switching. like it's changing values. With this picture you can see that when our LDR value was 833 lux, our angle on the servo motor was 38 degrees. So in truth, during this period of time, during these values, the light bulb was showing minimum light. And I would advise you to choose this device because it's really successful, and it can, upon many surveys I've conducted with my friends, families, and strangers, I've seen that they really loved the way this project works and the way it doesn't really need much human interaction for it to work. And basically, as time goes on, I can produce a different variation of this, where it can be a light bulb outside your home, and the LDR this time will be interacting with the sunlight, the sound waves. Sorry, will be interacting with the sound waves, and as daybreak comes, as the sun settles, you would be able to see the increase in the light intensity, and as the sunrise comes up, you also see that the light would be diminished. And if you want to know more about this device, I can tell you for a fact that is at this right now is estimated at 119.99 dollars. This value might increase or decrease depending on how the economy rises and falls. And it has a lifetime of 6 years, so it can operate 6 years without any troubles. And despite I used a incandescent light bulb, it can actually be used with an LED, a halogen, or a CFL bulb. Now, for my fellow engineers and DIY lovers, or basically anyone interested in knowing how and to knowing how and they can build their own device like this, I'll be showcasing the code I used and the flowcharts on the red I built. As well, at the end of the video, I'll be showing you inside the device itself to show you the connections I made. So basically, this is the code I created, where we have our LDR pin, which I chose on the analog pin 0. I created an object for the servo. And in the void setup loop, I used the serial board 9600, and using pin mode, I set the LDR to the inputs, and also I attached my servo to pin 9, the digital pin 9. And in the void loop, the LDR value is also there. It reads the analog. We are reading our analog value from analog pin 0 to collect, and that's our LDR value. And for the servo's position, that's the servo's angle, we create a map using the LDR's value, and we know that our LDR goes from 0 to 1, 0 to 3, and our servo's angle goes from 0 to 180. So then we create a kind of inversely proportional situation using this line. and then we write, and then in this line we are just basically sending these values onto the Arduino so that it can move the servo to that angle, and then we just serial print our values with a delay of 500 milliseconds. And this is our Node-RED dashboard interface, where I told you before that we serial print our values. In truth, it actually comes to the serial port over here. This serial port goes to a function node. This function node then separates the LDR value from the servo's position. Then I send the LDR's value into another function so that it can specify, so that I can separate the values like individually. So then the LDR value comes here and the servo motor's value comes here. Then I change the value into a number so that it can be read on the dashboard. I did the same thing for the servo motor, and then I send that value into, to view it on our on our Node-RED dashboard, I send it into a gauge, and also I feed that same value into a chart so that we can see the changes in real time on the chart. I also do the same thing for the servo's angle with a chart as well. I'll be now showing you inside of the device. So basically this is our inside of the device, and over here you can see the connection for the LDR. It has a voltage divider connection with a 10K resistor, and then we can see our servo's motors connection, which is then mechanically connected with the dimmer switch, which is, so all this parts from the servo motor to the Arduino is the DC part, which is powered by this cord. And then we have our AC part, which the the dimmer switch is connected with the light bulb, which is protruding outside. And you can see we need to make sure that our connections are insulated properly, because using AC power can be detrimental, so we need to be careful about that. And then I created a space so that I can make my connection onto the outlet. So basically that's the inside display of the device. So anyone trying to build such a device, these are the connections that are made, and in truth it's very simple to make. Thank you for watching this video, and I hope you enjoyed it. See you next time.